Hi guys, good morning to all of you. Yes, guys, can you hear me? Yes, can you hear me? Anyone can you respond? Yeah, thank you for your response. Yes, if anyone unable to hear me, yes, unable to hear me, please rejoin. Rejoin into session. Just rejoin into session. Rejoin
Hello.
into. Okay.
We
Yes,
are not able to hear you.
Yes, if anyone unable to hear me, please rejoin. Yes, if anyone unable to hear me, just rejoin into session. That's it here. Just rejoin. Simple solution. If anyone unable to hear me, just rejoin. Just rejoin. Okay, if anyone unable to hear me, just rejoin into session. Enough. Okay, fine. I think everyone is able to hear me. So let us start our session. Let us start. Yes, yesterday's class, just introduction is discussed just about course plan. Next, what are the course contents about myself? These things were discussed. Next, what is big data? Just introduction given. Yes, today let me review yesterday that big data concepts here. Big data. What is the only definition we discussed yesterday? What is big data? Yes, let me review. After that, I will go to new topic. So first of all, yes, let us have a review on the yesterday's big data. Yes. Okay. Yes, no session. Yeah, this is a session, recorded session. Yesterday's recorded session. This is yes, next term. Yes, for you. Document. Yes, big data introduction. Yes, I'll share this. I'll share this one here. Introduction. Yes. So first of all, what is big data? This point we should discuss. What is big data? So what is big data? So first point, what is big data? Next, what is Hadoop? First, we'll see what is big data. Next, we'll see what is Hadoop. So first of all, what is big data? What is big data? Suppose, for example, here, yes, I have a company. Yes, I have a company. Yes, with storage capacity. Yes, suppose I have some company here with storage capacity. Storage capacity with storage capacity of 100 terabytes. Storage capacity of 100 terabytes. Database, the database storage capacity. Suppose let us take database here. So our database server this is. So database server here. Yes, storage capacity. Suppose this is 100 TB. 100 TB. This capacity is 100 TB. Storage capacity 100 TB. Okay. Suppose 5 years ago started company. 5 years ago. Suppose 2015 started company. Right, okay. Yes, so to 2015 year, that year some transactions, some data generating here. So first year less number of transactions, less number of transactions, less data, right? So next year maybe transaction increasing, right? Because here yes yes in long run, yes, increasing business, right? Initially some business here Yes, next year maybe business increasing, right? Because of long run business increasing. So 2016 business, more business and more transactions, more data, right? Yes, 2017. Yes, still business continuously. Yes, once you providing quality service here, that business increasing continuously. 2015, 2016, 2017, so 2018, yes, 2019, yes. So 2019, now 2020, this year, current year. Yes, after 2019 to 2020, current year, for the current year, suppose the server failed. Does that completed data field, this field here, because still data is there. Still data is there to store it, right? 2020 current year data. Year data, right? For this, yes, so this is filled. This is filled, but no space available. Still data is there. Still data is there. That means that incoming data is more than the capacity, right? The data, whatever data generating, there is a more than capacity. That is called big data. So what is big data here? Yes, any amount of data. Yes, any amount of data. Any amount of data. Any amount of data which is beyond of storage limits. The amount of data which is beyond of storage limits. Beyond of storage limits. Any amount of data which is beyond of storage limits. Any amount of data which is beyond of storage limits called as big data. That's big data. So this is big data definition here. Is called as big data. So any amount of data which is beyond of storage limit is called as big data. This is simple definition of big data. Okay, any amount of data which is beyond of storage limit called as big data. Yes, I'll give one more example here. Suppose your laptop, your personal laptop, right? Suppose your personal laptop, okay, with 1 TB space, right? With 1 TB disk space, right? Suppose last year purchased. Yes, your laptop purchased in the last year. Okay. Yes, your laptop purchased in the last year. Somewhere getting disturbance. Okay. Please try to avoid the noise from your background. Yes, maybe Ashutosh. Okay, no problem. Yes, please. Yes. So personal laptop. Suppose personal laptop with 1 TB free space, 1 TB space, right? So initially 1 TB. Yes, suppose laptop purchased in the last year. Last year laptop purchased. Okay. Yes, storing something, maybe softwares, downloading softwares, storing into your laptop, right? Okay, suppose sometimes movies, downloading movies, storing into your laptop. Maybe your family, yes, function related some videos, audios, all these, right? Like this continuously we are storing, right? Suppose disk filled, still data to store. Yes, you want to download some other videos, okay, or yes, storing some other videos, but space is not available. That means you facing big data problem. Yes, your laptop disk capacity is only 1 TB, but data is more than 1 TB, right? But data is more than 1 TB. Data is more than 1 TB, right? So data is more than 1 TB here. So that means you facing big data problem, right? So you facing big data problem. So you get data. So whatever data is there, that data is more than the capacity, right? What's the capacity? Only 1 TB space. Only 1 TB space. But data more than 1 TB, right? That is called big data. Now you can 100 TB. Yes, maybe personal laptop, maybe company, right? Yes, anyone can. Data is more than the capacity here. Data is more than the capacity. That is called big data, right? So this is about big data definition here. So data is more than capacity. Okay. So any amount of data. So any amount of data which is beyond of storage limit. Any amount of data, maybe 1 TB data, maybe 10 TB data, maybe 100 TB data, maybe yes, petabytes of data. So any amount of data which is beyond of storage limit. Beyond of storage limit called as big data. So any amount of data which is beyond of storage limit called as big data. So this is big data definition. Right, okay. Next, one more thing here. Yes, one more. See, 1 byte. 1 byte equal to how many bits? 1 byte equal to how many bits? 1 byte equal to how many bits? No one idea? 1 byte equal to 1 byte. 1 byte equal to how many bits? 1 byte equal to 8 bits. Just only 8 bits. 1 byte equal to 8 bits. 1 byte equal to 8 bits. 1 byte equal to 8 bits. Okay. 1 byte equal to 8 bits. Next 1 KB, 1 kilobyte equal to how many bytes? Yes, I'm here to explain everything. Just I'm asking your idea. That's it here. I'm asking. Okay, I'm here to explain everything, so no worry. So 1 byte equal to 8 bits. 1 KB equal to 1024 bytes, right? 1 KB equal to 1024 bytes. Yes, sir. Next, yes, MB. Next is MB, right? 1 MB. Next equal to how many bytes? 1 MB. 1 MB equal to how many KBs here? 1 MB equal to 1024 KB, right? So these all are data measuring volume units here. Data volume units here. Data volume. So how much volume per disk? Like 1 MB, 500 GB, 100 GB volume of your disk, right? Volume. That is called as volume here. Volume. Okay, how much volume here? Like 1 KB, 1 MB like this. So 1 MB equal to 1024 KB, right? Yes, after MB. Next what? GB. 1 GB. 1 GB equal to, yes, 1024 MB, right? 1 GB equal to 1024 MB. So 1 GB equal to 1024 MB, right? 1 GB. After MB, next GBs. Yes, after GBs, what is next here? Terabytes. Okay. Yes, GB. Yes, next. C. KB means kilo. 10 to the power of 3. Yes, MB. 10 to the power of 6. Next, 10 to the power of. Yes, GB is 10 to the power of 9. 10 to the power of 9 here. Next, TB 10 to the power of 12. So 1 TB equal to 1024 gigabytes, right? 1024 gigabytes. Right, okay. Next, after terabytes, next watch here. Petabytes. 1 petabyte is equal to 1024 terabyte, right? 1024 terabytes. Okay. After petabyte, next what? Exabytes. 1 exabyte equal to 1024 petabytes. After exabyte, next what? Zettabytes. 1 zettabyte is equal to 1024 exabytes. That's it. Okay. See here, 1 byte. Yes, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, and zettabytes. So kilobytes, 10 to the power of 3, 10 to the power of 3, 1000, kilo means 1000, right? 10 to the power of 3, 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, 10 to the power of 15, 10 to the power of 18, 10 to the power of 21, right? This is okay, right? In this, up to GBs. Up to GBs is a small data. Up to GBs, it's a small data. This up to this is small data. Up to this is small data, right? From terabytes to zettabytes. Terabyte, zettabytes here. From yes, from terabytes to zettabytes. Zettabytes, yes, it's a big data. Comes in a big data. This range comes in big data. So this is big data range. Terabytes to zettabytes comes in a big data. So this is big data range. Terabytes to zettabytes. This range. Okay. So terabytes to zettabytes. This range is a big data. Right. Okay. So this is what is big data, right? Okay. Yes. What is big data? Definition. Definition of what is big data. So any amount of data which is beyond of storage limit called as big data. Any amount of data which is beyond of storage limit called as big data. Okay, called as big data. Okay, fine. Yes, up to GBs is a small data here. Terabytes to zettabytes. This range comes under big data. Terabytes to zettabytes. This range is big data. Okay. Yes, what are the examples of big data? Some examples. Let us see some examples here. First one. Best example, historical data. Historical data comes under big data. Historical data means old data. Maybe 2 years of data, 3 years of data, 4 years of data, maybe 10 years of data. That is total historical data, right? Yes, huge amount of data. Suppose current year data means just it's a small data. Current year data, no problem, no issue. But historical data, it's a big data. That historical data is a big data. Okay, last 3 years, last 4 years, old data. All the old data, it's historical data. Okay, yes. No, it's live. No, just I'm giving review. Yes, Akansh, just I'm giving review. Just review yesterday's class review. First to 10 minutes review. After that, I'll go to new. Okay. Yes. So historical data. Yes. So historical data. Historical data is the best example. Right, okay. Next, yes, like this, so many examples. Social network sites. One more example here. Social network sites. Social network generates sites generating lot of data, right? Yes, like Facebook generating 4 petabytes of data per day. Facebook generating 4 petabytes of data. Okay, next, Google search engine. So Google search engine generating lot of data every day. Next, WhatsApp. Yes, WhatsApp. Yes, WhatsApp generating lot of data, right? Next, Twitter data, right? Yes, all these comes under, yes, big data examples here. Yeah, these applications are generating big data, right? Yes, next, yes, online shopping here. Yes, online shopping. Yes, like Amazon. Yes, Amazon online shopping, right? That is generating lot of data every day. Now, Flipkart generating lot of data every day, right? Okay. Next, yes, like banking applications, banking. Yes, banking data, right? It's a big data here. Lot of data generating every day in banking. Banking, they should maintain lot of data, right? Suppose some customer asking for 10 years of statement here. 10 years. 10 years, right? 10 years. Some customer asking for 10 years of statement, right? They should provide 10 years statement, right? That means, yes, they should maintain 10 years of data. Historical data, that historical data they have to maintain here. So banking data comes on big data. Next, one more example, stock exchange data. Stock exchange data here. Yes, stock exchange data. So these are some big data examples. Stock exchange. In stock exchange, lot of trading happening every day, right? Just like New York Stock Exchange, Bombay Stock Exchange, like this. These stock exchanges, yes, generating lot of data every day. Lot of data generating, lot of trading. So every share information they have to maintain. All the shares information. Suppose if you wanted to buy some share, yes, how can you buy it here? By considering all this share performance. Yes, last 1 week performance, last 3 weeks performance, maybe last 1 month performance here, last 3 years. So based on that last 3 years, so the stock exchange has to provide that historical data, right? So this is comes under big data. So these are some big data examples. Like this, so many examples we can discuss here. So many examples like transport data. Okay, next, medical data, insurance data. Like this, so many examples we can discuss. So these are examples of big data. Some examples. There are sources, different sources. Okay, sources of big data. Historical data, social network sites generating big data every day here. Online shopping generating big data here. Banking data, big data here. Stock exchange, it's a big data, right? Okay, yes, how to handle this big data? Big data. Yes, the traditional systems are not in a position to handle this big data here. Yes, the traditional systems are not in a position to handle big data here. Traditional systems like database servers, like Oracle database server, maybe MySQL database server, MySQL, next Microsoft SQL server, MS SQL. Yeah, these databases are not in a position to handle this, right? Yes, traditional systems like Oracle database, MySQL, next Microsoft SQL servers are not in a position, to handle this big data. Okay, not in a position to handle big data. Right? Traditional systems not in a position to handle all this big data here. Okay, so it's a big data, lot of many challenges here. Okay, yes. So the traditional systems, traditional database servers, traditional systems like Oracle database, MySQL, Microsoft SQL server. So these are in a position to handle big data, right? Okay, big data. Right, okay. Yes. Here from the big data, there are a lot of challenges. Yes. Here traditional systems has to face a lot of challenges. There are many challenges from the big data here. So traditional systems are not in a position. Traditional systems are not in a position to handle all the big data challenges. Okay. So first let us see what are the big data challenges. So what are the big data challenges here? So what are the big data challenges? Big data challenges. Okay, challenges, right? So what are the big data challenges? Okay, so big data, there are so many challenges from big data. Yes, how to are these main challenges? We'll see main challenges. Okay, yes, first one, Data storage. Main problem is data storage, right? Data storage. Main problem, data storage. With big data, main problem here, data storage. Data storage. Next, data processing here. Next one is data processing. Next one is data processing here. Yes, data storage. Next, data processing. Yes, big data. It's not easy to store data, right? Yes, Oracle database, MySQL, and these traditional databases are not in a position to store big data like petabytes of data or terabytes of data. So these databases are not in a position. These are not in a position to store. Okay, yes, store big data like terabytes of data or yes, petabytes of data. So they can't store it, right? Like data processing here. When it comes to data processing here, these traditional systems, Oracle database, MySQL, Microsoft SQL servers, these servers unable to process big data. They can process, but slowly processing here. Lot of time taken to process the data here. Okay, lot of time taken to process the data. So data storage, data processing, there are main challenges. Yes, apart from this here, apart from this, data storage, data processing. Next, yes, if it is big data, high-end hardware required. Next, one more challenge, high-end hardware. For big data, high-end hardware required. Okay, so data storage, data processing. Next, high-end hardware required for big data. Right, okay. Next, yes, very large files. Very large files. Okay. Yes, very large files. With big data, there is a chance of generating very large files. Okay, large files. Traditional systems can't handle large files. Traditional systems fails. Traditional file system like Linux file system, Windows file system. Linux and Windows file system fails to handle large files. Large files cannot be. So next, very large files. Next, backup. Next, one more. Yes, a very important one, backup and recovery. Backup and recovery task. Backup and recovery. So backup and recovery. So next is backup and recovery. So next, one more important one, disaster management. Disaster management here. Disaster. Yes, disaster management. Okay. So very high-end hardware required. So very large files. Okay. Yes, I'm saving this one. I'll share with you this. I'll share in WhatsApp group. Okay. Yes. I'll share in group. Yes. Now these are the big data challenges. What are the big data challenges? So these are the big data challenges. Okay, like data storage, data processing, high-end hardware, very large files, backup and recovery, net disaster management. These are the main challenges. Apart from this, many challenges are there that we'll see next one by one. Yes, many challenges are there here. So these things we'll see next year. We'll see one by one. Okay. So for data storage, data processing, high-end hardware, very large files, backup and recovery here, disaster management. Here traditional systems like Oracle database, MySQL database, Microsoft SQL servers, these are not in a position to face all these challenges. Okay. Next, Linux file system, Windows file system. These are not in a position to face all the challenges. So traditional systems are not in a position to face all the challenges. Then, which is the right technology? So what's the solution for this? All the challenges, what's the solution? For this Hadoop. Yes, Hadoop provides best solution. Hadoop provides best solution for all the challenges. Best solution. Okay, for all the above challenges. Okay, for all the above challenges. Hadoop provides best solution. Hadoop provides best solution for the above challenges. Okay, now let us see what is Hadoop first of all. Hadoop provides best solution. Okay, fine. Hadoop is the best technology to face all the challenges. So Hadoop provides best solution for all the above challenges. Not only many challenges, not only we have other challenges also. Others we'll see next. The actual topic I'll explain. Okay, these are main challenges. They are main challenges here. Apart from other challenges that we'll see next year. Okay, Hadoop provides best solution for the above challenges, right? Now question is what is Hadoop now here? What is Hadoop? So what is Hadoop, right? What is Hadoop? See, so first what is big data? It's clear, right? What is big data? For this, it's clear. What is big data? Yeah. Yeah. Yes. So what is big data clear, right? Can you hear me now? I think audio loss. Now it's restored. Hello? Can you hear me now? Yeah, okay, fine. Okay. Yes, sir. So anytime if you are unable to hear me, just ping me. Okay, sometimes due to network issues in online classes, due to network issues, loss of audio. Okay, just only matter of 1 or 2 seconds audio loss, that's it here. Automatically that is reconnecting. Okay, yes. Restoring audio automatically, just 1 or 2 seconds break getting. Of course, I'm repeating same topic 2 to 3 times. Yes, same topic. Yes, I'll be repeating. Not only every day, topics will be repeating, repeated explaining here. Don't worry. Okay. So Hadoop provides best solution for above all the challenges. For above all the challenges. Okay, for above challenges, right? So what is Hadoop now? Let us see. What is Hadoop? What is Hadoop here? What is Hadoop? Yes, Hadoop is a framework. Hadoop is a framework. Hadoop is a framework to store and process big data. Hadoop is a solution for the big data here to store and process big data. Yes, Hadoop is a framework. Hadoop just it's a framework. So what is framework? Framework means ready-made one. Yes, ready to use. Okay. Yes, Hadoop is a framework to store and process big data. To store. Yes, Hadoop is a framework to store and process big data. Fine. Yes. So exactly what is Hadoop here? Yes, Hadoop contains 2 modules. There are 2 modules in Hadoop here. There are 2 modules, 2 core modules. Okay. Next, apart from core modules, some sub-modules are available. Sub-modules will see next here. There are 2 core modules in Hadoop here. There are 2 core modules in Hadoop. There are 2 core modules in Hadoop. There are 2 core modules. First one is Hdfs. Second one, MapReduce. Yes, MapReduce. Yes, simply you can call as MapReduce. Yes, MapReduce. Hdfs and MapReduce. Okay, so there are 2 core modules in Hadoop. There are 2 core modules in Hadoop. First one is Hdfs. Next one is MapReduce. Hdfs and MapReduce. Okay, yes. What is Hdfs? What is MapReduce? Let us see. About Hdfs. What is Hdfs? Hdfs stands for yes, Hadoop distributed, Hadoop distributed, Hadoop distributed, Hadoop distributed file system, Hadoop distributed file system. HDFS stands for Hadoop distributed file system. Yes, so HDFS stands for Hadoop distributed file system. Okay. Yes. Here, what is distributed file system? We'll discuss. Just wait. So HDFS Hadoop distributed file system. So what's the purpose of this? To store the data. This is to store data. HDFS to store data like a backend. Like a backend. This is like a backend. Okay, HDFS Hadoop distributed file system to store data like a backend, like a databases. Like a databases, this is like a backend here to store data. Backend to store data. Right, next, what is MapReduce? Yes, MapReduce. MapReduce. So this is MapReduce. They are the Java programs. HDFS is a file system. Hadoop distributed file system. HDFS is a file system. What is MapReduce here? Java programs. Okay. So these are the files. Next, they are the Java programs. So MapReduce. So these are the Java programs. Java programs. Programs to process data. To process data. So to process data, right? Java programs. These are Java programs to process data. Data processing using MapReduce for data processing, Hdfs for the data storage. So this is like a front end, right? Front end to process data here. Front end, like a front end. Okay. So Hdfs like a backend to store the data here. Backend is to store the data. Yes, mapped is like a yes, they are Java programs to process data. Java programs to process data. So Hdfs and mapped is. Yes, okay. So first let us start discussing with Hdfs. So what is exactly Hdfs? What is exactly Hdfs? What is distributed file system? So what is distributed file system? First we'll see here. Okay. So in Hadoop there are two core modules. There are two core modules in Hadoop. First one is Hdfs. Second one is MapReduce. Hdfs, next MapReduce. Hdfs Hadoop distributed file system. This is to store data like a backend. So like a backend. MapReduce. They are the Java programs to process data. To process data like a front end. These are like a front end. Okay, fine. Now first DFS. What is DFS? Distributed file system. DFS means distributed file system. What is distributed file system? So what is distributed file system here? Yes, in DFS here, yes, file. In distributed file system, yes, 1 second. Before this distributed file system, first let us see about traditional file systems. First about traditional file systems. Traditional file systems. Yes, here. Yes, let us see all the things here. Yes, all the challenges. Traditional systems versus Hadoop. Traditional systems versus Hadoop here. First file system. Traditional file system. Yes, versus Hadoop file system here. Hadoop Hdfs. Hdfs, right? Traditional file system and Hadoop. Yes. First, let us see about traditional file system. Yes, traditional file system. Yes, Linux and Windows. These are traditional file systems, right? Linux and Windows are traditional file systems. So Linux and Windows are traditional file systems. Right, okay. Yes, any file system. Yes, in any 1 second. Yes, Windows file system. Yes, Windows file system is Windows file system. Yes, Windows file system is NTFS. Sorry. Yes, Windows file system is NTFS. So the NTFS, right? NTFS. Yes, old Windows, old versions FAT32, F8032. Yes, old systems F8032. F8032. That is old version. Old versions. Not now here, old versions. Old versions is F8032 here. Yes, latest version is NTFS. So this is yes, new version here. New version. Right, okay. New version like yes, new versions. NTFS for new versions. Yes, new versions like Windows. Yes, Windows 7, 8, next 10, 12. Right, next apart from this, yes, Windows XP. Okay, next Windows 2000. These are yes versions like this. So these all are comes in yes NTFS. All these new versions like Windows XP, next Windows 2000, Windows 7, 8 and 10, 12 like this. These all are new versions. They are NTFS. So NTFS, right? F8032. These are from the FAT32 old versions. Old versions like Windows 95 and 98. Windows 95, 98 old versions. Okay. Yes. See, Windows 95, 98 does not support networking. There is no networking facility. Yes, NTFS, networking technology file system here. NTFS. Okay. So NTFS is new version. New versions like Windows XP 2007, 8, 10, 10 like this. Yes, here F8032 it's an old version. So they are old version, right? So these are yes new version. So this is for old version, right? Next, Linux file system. When come to Linux file system here, yes, Linux file system. Yes, Linux file system. Linux file system is yes ext2, yes ext3, yes ext4. Second extended, third extended, fourth extended. We are Linux file system. Okay, right? Yeah, they are the file systems here. These traditional file systems. Okay, The traditional file system, right? Yes, in any file system, hard disk divides into multiple blocks. Yes, with any file system, yes, with any file system, yes, hard disk divides into multiple blocks. Just a hard disk dividing into multiple blocks. Hard disk divides into multiple blocks. Hard disk divides into multiple blocks. Right? Yes, with any file system, hard disk divides into multiple blocks. Yes, what is block? Let us see what is block here. Yes, something like let us. This is hard disk. This is hard disk. This is hard disk, right? In hard disk, block one. Okay, block two. Yes, block three. Like there are some blocks. Block four like this up to number of blocks, multiple blocks, up to n number of blocks. Block n. Okay, so these blocks, what is block exactly we'll discuss. Block n like this, multiple blocks. Block 1, 2, 3, 4, 5, 6 up to multiple blocks, right? So these depends on storage capacity of disk and file system. Okay, so what is block here? What is this block? What is this block here? What is this block here? So size of this block depends on file system. Size of this block depends on file system here. File system. Yes, in traditional file systems, see this. Traditional file systems, Linux or Windows. Okay. Traditional file systems, Linux or Windows, size of each block is 4 KB. Traditional file systems like Windows and Linux. Yes, Linux. Windows and Linux here. Linux. Yes, size of each block. Yes, size of each block. Size of each block is equal to, yes, size of each block equal to 4 KB. Just it's a 4 KB. Size of each block is 4 KB here. Okay. Traditional file systems like Windows and Linux base. Windows and Linux base. Yes, here size of each block is only 4 KB. Right, okay. Same thing. If it is Hdfs. Yes, in Hdfs here, size of each block. Hdfs. Size of each block. Size of each block. Each block depends on version. Depends on version. Hadoop versions here. Yes, Hadoop versions. First version of Hadoop. Hadoop 1.x version. Yes, in this size of each block is 64 MB. It's a 64 MB. Okay, 64 MB. Size of each block in 1.x version. Size of each block. Size of each block is equal to, yes, 64 MB. Okay. Yes. Next, in second version of Hadoop here, Hadoop 2.x and 3.x. or 3.x. Size of each block is 128 MB. Yes, why I am explaining all the things here? Yes, to understand storage, I need to explain this one here. To understand storage of data, I have to explain this so that you can understand. Otherwise, not easy to understand. So here size of each block depends on version. Here 1.x version, size of each block is 64 MB here. Next, second version of Hadoop and third version, size of each block is 128 MB. Here, yes, in traditional systems 4 KB. So this is, yes, Linux hard disk 4 KB, Windows hard disk. In your system there is a Windows, right? In your system there is a Windows. C drive, D drive, we have some partitions. C drive partition contains some blocks. D drive partition some other blocks. Next, E drive some other blocks like this. Suppose this is C drive partition. Maybe this D drive partition. Maybe E drive partition like this. That partition dividing into blocks. So what is that block? That block contains, yes, 4 KB. Yes, if it is Windows Linux files, the size of each block equal to 4 KB. Only 4 KB. But in Hadoop, it's a 128 MB. We are going to work with, yes, second version of Hadoop and third version. So for that reason, 128 MB. Size of this each block is 128 MB. That's okay. Now here, so what is main difference between traditional file system and Hdfs? Traditional file system and Hdfs. See, in traditional file systems here, yes, in traditional Yes, in traditional file systems, file systems, one file, yes, one file storing on only one computer, not multiple computers. A file storing on only one computer here. So one file storing on just storing on only one computer, storing on only one computer here, only one computer, okay, not multiple computers, not possible. Even networking facilities are here, one file always storing on only one system here, one file is always storing on only one computer. Not only file here, some database table. Let us take database table here. So database table, yes, even database also, database table, yes, one table, only one server, not multiple servers. Okay, yes, a table can be stored into only one server, here. A table can be stored into only one server, not multiple servers. Only one server, yes, cannot table, yes, you can't split the table, you can't break it, table cannot be break it here, we can't break it here, so we can't break the table. So one table, only one server, so cannot be, yes, cannot be stored on multiple, cannot be stored onto multiple servers here, cannot be stored, okay, so cannot be stored on multiple, yes, multiple servers, okay. So in traditional systems here, one file always storing on only one computer, okay. Database tables, a table can be stored into only one server, not multiple servers, so it cannot be multiple servers, so this cannot be multiple server, right? This is about traditional file system, right? When you come to DFS, yes, now let us see DFS. In DFS here, file splitting into multiple parts. A file split into multiple parts and distributing into multiple systems in a network, multiple computers. Okay, in DFS here, yes, in DFS, distributed file system. In distributed file system, yes, a file break into multiple parts. A file break into multiple parts, and distributed and storing onto, yes, storing onto multiple computers. Yes, in DFS here, a file breaking into multiple parts and storing on multiple computers, multiple, yes, multiple computers in a network. So called as the distributed file system. Okay. Yes, in distributed file system here in DFS, a file break into, yes, break into multiple parts. That breaking into multiple parts can storing in multiple computers network. So this is called distributed data storage. Okay, this is called as distributed data storage. Called as distributed data storage, right? This is distributed data storage. That means one file breaking into multiple parts. And storing on multiple, yes, multiple computers network. So this is called distributed data storage. Called as distributed data storage. Clear? Yes. Next, what is Hdfs? Let us see. What is Hdfs? Hadoop distributed file system. So Hdfs, Hadoop, yes, distributed, Hadoop distributed. Hdfs, Hadoop distributed file system. Hadoop distributed file system. So what happens in Hadoop distributed file system here? Okay. In Hdfs, what happens? Hadoop distributed file system. Yes, see, in Hdfs, yes, if a file breaking into multiple blocks, see, disk dividing into multiple blocks, right? Block 1, block 2, block like this. A file divides into multiple blocks. A file divides into multiple blocks. Divides into yes, multiple blocks. That means 128 size of each block is 128 MB. So dividing into file, dividing into multiple blocks means 128 MB is one block. Next 128 next block. Next 128 next block. Next 128 next block like this. So in Hdfs here, yes, a file divides into multiple blocks and distributed to multiple nodes, in the cluster, Okay, so what is node, what is cluster? Again, it's a new terminal, right? Yes, on Hdfs, a file divides into multiple blocks. So what is block we discussed? What is block? The size of each block in Hadoop, it's a 128 MB. So Hdfs block is 128 MB, next 128, next 128, next 128, next 128 like this. It's a 128. That block is cleared. Okay. So here your file divides into multiple blocks. So block is cleared. That means that file dividing into 128 MB like this. So dividing to 128 like this. After those blocks are distributing onto multiple nodes in cluster here. Dividing into multiple blocks and distributed onto multiple nodes in the cluster. What is cluster here? Hadoop network called as cluster. Hadoop network is a cluster. What is exactly cluster? We'll discuss next. I'll explain very clearly. Cluster. Hadoop cluster means nothing but Hadoop network. Complete Hadoop network. In Hadoop network, maybe 100 computers or 200 computers. That whole thing is called one cluster. Hadoop cluster. Nothing but it's a Hadoop network. Hadoop network, right? Yes, what is node? Node means computer. Yes, node means computer, like your computer. Yes, Hadoop network and computer, right? They are called as nodes. Hadoop networking LAN, that Hadoop LAN, right? Hadoop LAN, local area network. That Hadoop LAN network and is what? Nodes, nothing but computers. Yes, like your office, in office working with some computers, right? Okay, maybe college, lab, many computers, right? Yes, all interconnected computers network. That is nothing but cluster. That is one cluster. Hadoop cluster means Hadoop network. All Hadoop systems placed into one network is called as cluster. Right? Okay. Yes, in that nodes. Node means it's a computer. All the computers called as nodes here. Node means no confusion here. Yes, in Hadoop terminology is a node here. Node means it's a computer. Node means just it's a computer. Okay, fine. So on Hdfs, a file divides into multiple blocks and distributing onto multiple nodes in the cluster. Fine. Okay. Yes. Next. For example, here. Name of the file one with 100 GB data. Yes. File one with 100 GB data is equal to how many blocks? That is question here. How many blocks? File one with 100 GB data is equal to how many blocks? Okay. Yes, here size of each block is equal to 128x. Size of each block equal to 128 MB. Size of each block is 128 MB. Now 100 GB data, how many blocks? Yes, 100 GB. First of all, let us take 1 GB data. 1 GB data equal to 1024 MB, right? 1 GB data is equal to 1024 MB. That means 1 GB equal to how many blocks? 1 GB is equal to how many blocks? 1 GB equal to how many blocks? Let us see. 1 GB equal to how many blocks here? That means 1024 divided by 128 MB, right? Yes, size of each block is 128 MB. Size of each block is 128 MB. Size of one block is 128 MB. So 1 GB equal to 1024 MB, right? That means 1024 MB divided by 128 MB, right? So 1024 MB divided by 128 MB. This is equal to 8. This value 8. Just try that. 800 plus 160, 960 plus, yes, 64, 1024. That's it here. Okay. So totally 1024, right? So this is nothing but 8 blocks. It's 8 blocks, right? It's 8 blocks, right? 1 GB. So here 1 GB is equal to 8 blocks. 1 GB equal to 8 blocks, right? 1 GB equal to 8 blocks. 1 GB equal to 8 blocks. Then 100 GB equal to how many blocks? Yes, 100 GB equal to how many here? 1 GB equal to 8 blocks. Then 100 GB, how much here? 800 blocks, right? Just it's a 800 blocks. That's it. Okay, so 800 blocks, right? So that 100 GB data divides into 800 blocks and distributing onto multiple nodes cluster. Yes, who will distribute into multiple nodes in cluster? We'll see that. We'll see. Just wait. So this is, see, Hadoop distributed file system, HDFS. So in HDFS, a file divides into multiple blocks. Block size of each block equal to 128 MB. Size of each block equal to 120 MB. That means your file divides into 128 MB, 128, 128, next 128, next 128, next like this. Dividing into 128, 128 like this. After that, distributing onto multiple nodes in the cluster. Cluster means Hadoop network. Total Hadoop network is called a cluster. Next, nodes means computers. Okay, 1 second. Let me show that Hadoop. Yes, our company. Yes. Yes, our company data center. Yes, this is Hadoop main document. This document is for you. This is data center. Data center. Rack 1, rack 2, rack 3, rack 4, like multiple racks. Okay. Like a supermarket, right? If you go to supermarket, there are so many racks. In racks placing all the items, right? In racks placing all the items. Like supermarket racks, here are racks. But these racks are costly, specially designed racks. Not like supermarket here. Yes, somewhat looking like here. Yes, here computers, this side computers and that side computers. This side and that side. This side, that side. So this is our data center. Okay, our data center, Chicago. D-World company, data center at Chicago. Yes, so this is our data center. Okay, right? This is. Okay, all the racks. In this placing all the computers, here computers, all the computers placing the racks, right? All the computers inside of racks. Okay, so placing a network connectivity, right? All these connections here. Networking connection. This is called data center. Data center, right? It's a data center. Okay, fine. Yes. So cluster is nothing but Hadoop network. That nodes means nothing but computer, like your computer. Your computer, like yes, your computer like a hard disk, RAM, memory, and everything is like same as like our computers. What are the computers we are using? Same, but those are high-end systems. Our computers are low-end systems, but those are high-end systems. That's the difference here. Okay, so here file 1 with 100 GB data. How many blocks here? 1600. Sorry, 800 blocks. Okay, so 128 MB size of each block is 128 MB. That case, it's 800 blocks. Suppose in 1.x version size of each block equal to 64 MB. That case is a 1600 blocks, a double. Okay, yes. Hadoop 1.x version. Hadoop 1.x version. Yes, Hadoop 1.x version. Here. In this version, the size of each block is equal to here. Yes, size of each block is equal to how much here? 64 MB. 64 MB. Then yes, 100 GB data file. Then 100 GB data file. Yes, is equal to how many blocks? 1600 blocks. That's it here. Double. Yes, if it is 128 MB, so getting 800. 64 MB is 1600 blocks like this. 1600 blocks. Okay. So size of this block is 128, 128, 128, 128 like this. That's it here. Size of each block. Okay, right? Yes. Okay, fine. So this is about blocks on this. Now let us come to Hadoop, that network, Hadoop cluster. Hadoop cluster. Let us see what is Hadoop cluster here. Hadoop cluster. Okay, Hadoop cluster. Yes, cluster architecture. So once explain architecture, you can understand here. Hadoop cluster architecture. Hadoop cluster is a master and slave architecture. Yes, it is a master and slave architecture. Master and slave here. Master, it is a Yes, Hadoop cluster architecture. It's a master. It's a master and slave. It's a master and slave architecture. Master and slave architecture. Master and slave architecture. Master and slave architecture. Right? It's a master and slave architecture. So what is master? What is slave here? Master. Yes, everything is server. Master servers and slave servers. Yes, in Hadoop everything is server. In Hadoop everything is server here. Master servers and slave. What is master? What is slave here? See, master is like a manager. Slave is like an employee. Master is like a manager. Slave is like a employee. Yes, manager, employee here. Manager giving instruction to employees, right? Next, employees have to work as per the manager instruction, right? Manager is experienced guy. Which is experienced is giving instructions. As per instructions here that the employee has to work. Okay. Yes, maybe software projects or maybe mechanical, civil, any field, there is a manager employees. Okay. So here master is like a manager, slave is like a employees. Master is like a manager here, slave is like a employees. Okay. Yes, master, yes. Master, yes, he is like a master is like a master is like a manager. Master is like a manager. Master is like a manager. Okay. So master is like a manager. Okay. Yes. Master is like a manager. Next, slave. Slave is like a employee. So working like employee, right? Slave is like employee. Master is like a manager. Yes, slave is like employee. See this document. Yes, I am sharing. That's the reason I am writing notes also here. Okay. Yes, actually main document is these are main documents. Main documents. Yes, today topic. What is big data? Definition. What is big data? The definition. Any amount of data which is beyond of storage capacity called as big data. Okay. Big data means really it's a big data. It's a collection of large data sets that cannot be processed using traditional computing techniques. Okay. 1 byte equal 8 bits, 1 KB, 1 MB, GB, terabyte, petabyte, exabyte, zettabytes. What we discussed today here. Next, what comes in big data like historical data, black box data, social media data, all the stock exchange data, transport data, search engine data. Next, other examples, banking data, online shopping, insurance, medical data. All this comes in big data, right? Yes, now this topic is going on big data challenges. Okay, data storage, data processing, very large fields. Yes, high-end hardware, backup and recovery, disaster management. Now this topic is going on. That's it here. Yes, everything clearly is there in documents. Everything clearly is there in documents. Okay. Yes. Yes. Apart from that, I'm sharing daily document also. Okay. Today I'm creating group. So once a group creation is done, I'll share it. Yes. Today I'll be creating group. Okay. Yes. Yes. 1 second. Still anyone pending, guys? 1 second. Yes. So let us continue. So master is like a manager, slave is like a company. Sorry, like a employee, manager and employee. Let us see. Master and slave architecture. Let me draw this architecture here. Master and slave. Yes, master is name nodes. Name nodes. Yeah, name node. It's a master. So name node giving instructions. Okay, name nodes. Next, slave nodes. Yes, data nodes. Is data node to store actual data. Yes. So name nodes and data nodes. So name node is a centralized controller. So this is main in a Hadoop cluster. name node, next data node. So next data node 1, like this data node 1, yes, data node 2, yes, in shortcuts we can write dn, name node nn, next dn, data node 1, data node 2, like this. Next data node, 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 next data node. Yes, multiple data nodes in class here. Okay. Yes, like this. Multiple data nodes, many number of data nodes. Data node is to store actual data. So data node 1. So data node 1. Okay, right? Data node 2, data node 3. Next data node 4. Next data node 5. Yes, data node 6. Like this, multiple data nodes. Data node n. Yes, all the data nodes communicates with name nodes. There's a communication system between data node and name nodes. So data node and name nodes. Okay. So there's a communication here. Yes, every data node communicates with name nodes. Okay. Like a manager employee communication, everyone communicates with name nodes. Everyone just communicates with name node, like a relation between employees and manager here. Okay. Yes, just everyone communicating with name nodes. Yes, everyone, all these name nodes communicates with name nodes. Yes. What kind of communication will see next here? All the data nodes. Yes, now this is called a master. Yes, name node, it's a master. So this is called master node. It's a master. This is master. So this master giving instructions here. So this is called as master. So this is master. It's a master node. So this is master. The master node, right? This is master node. Yeah, this is master node. It's a master node. Next, all they are called as slaves. All they are called as slaves. Okay, slave nodes. All these are called as slave nodes. They are slave nodes. All they are slave nodes. Master and slave. It's a master and slave architecture. All they are slaves here. All they are slave nodes. Slaves. Slaves. Slave nodes are to maintain actual data of the file. Slave nodes to maintain actual data of the file. Master node giving instructions. Master node giving instructions. Slave nodes, data nodes are working as per instruction from the name nodes. So this is master and slave architecture. Clear? So master name node is a master. Yes, slave nodes are data nodes. Yes, name nodes. Name node is a central controller of Hadoop. So your name node will give the instructions to all data nodes. Okay, right? All data nodes. Yes, data node is to store actual data of the file. Actual data storing here. So first your request. So first your request simply goes to name node. Client, yes. Yes, end user request or client. Yes, end user. End user means who is using Hadoop cluster. End user request. End user request simply goes to yes, name nodes. End user request goes to name nodes. End user request goes to name nodes. Get that request. That request could be data loading or job submission. Only two things in Hadoop here. Either data loading or job submission. Job submission. Either data loading or job submission here. So end user request, data loading or job submission. That request goes to name nodes. Simply that request goes to name node, right? Okay. So first step. Let us see data loading. Data loading happening here. Let us see about data loading. Okay. One sec, let me take the copy of this cluster here. Copy. So first, data loading request, data storage. So this okay. So this is class end user request, data loading or job submission. How data distributed, storage, data storage, right? So first data storage. Yes, how the data storing. When you try to load any file here, so name node taking your file data and dividing into multiple blocks and distributing onto multiple nodes. Now let us see data storage. data storage. Data storage, right? Data storage. See, first one data storage. Yes, big data challenges, first one, right? First one. Now this we are going to discuss. Till now, just Hadoop industry, just what is Hadoop, what is DFS, what is master and slave, just introduction. Yes, more about this cluster we'll discuss very clearly. That internal architecture later we'll discuss. Okay, later I'll explain. We have separate topic on this. Later we'll see. Okay, yes, now get data storage. First, data storage, let us see traditional systems. Traditional systems versus Hadoop. Traditional systems versus Hadoop. This point we should discuss. Okay. So first we'll see traditional systems. How data storage in traditional systems. First, let us see about traditional systems here. Traditional systems. Traditional systems, for example, Oracle database. Oracle database. Oracle database, right? Suppose let us take Oracle database. Traditional database, Oracle database. How the storage here? In Oracle database storage. Suppose initially Oracle database, let us take database server. Initially database server. This server, yes, is configured with 10 dB first. Initially with 10 dB. 10 dB, right? Initially 10 dB. Database setup is done with 10 dB disk. Support 10 dB disk filled. Then DBA will add next space, adding space. Maybe 2 TB disk adding here. 2 TB disk. 2 TB disk. So why 2 TB? I'll tell you. Suppose for example, instead of 10 dB here, initially database at 2 dB capacity. Initially database capacity 2 dB. Database capacity 2 dB here. So 2 dB filled here. Then you will add next 2 dB. Next 2 dB. So filled next 2 dB here. So this also filled here. Next 2 dB, right? Like this, increasing volume like this. First initially 2 dB. Next 2 dB discarded. Next discarding like this. Like this, you will increase the volume here. Just increasing volume here. So initially just only 2 dB, right? Initially 2 dB capacity, right? 2 dB. So next 2 dB, next 2 dB adding like this, like this, increasing volume, right? Increasing volume like this, right? Yes, this is called vertical scaling. Yes, Oracle database follows vertical scaling. What is vertical scaling here? Yes, it's a vertical scaling. So it is a vertical scaling. It's a vertical scaling. This is called as a vertical scaling here. So what is vertical scaling? Yes, it's a process of increasing capacity of database server. What is vertical scaling? It is a process. It is a process of increasing capacity of database server. Right? Capacity of database server here. Just increasing capacity of database server. Just increasing capacity of database server, right? Yes, initially 2 dB, next 2 dB, next 2 dB like this. Yes, 1 second here. How you will increase that capacity? 2 dB adding here. How can here? How? Yes. See. Yes, in a computer here. Yes, a computer motherboard. A computer motherboard consists of 12 slots. In motherboard there are 12 slots. All LUNs also you can see here. LUNs. That we can say LUNs also. Slots. Okay. Each slot one disk added here. Okay. Yes, disk can be added to slot. Disk can be inserted into slots. So disk can be inserted. Okay. Disk can be inserted into slots. Disk insertion. Yes, hard disk. Just try to check your system here. In your system, they say yes, hard disk and cables, right? Hard disk. Yes, you can see that. Hard disk plug in with motherboard. One second. Images. See, this is these things you can see. This is plugin, right? Hard disk plugins. You can see that wide connection like once. Yes, there are slots here. Disk adding to this. This is your hard disk, right? Hard disk. Hard disk. See this. Motherboard to this motherboard. Adding, right? Yes, adding all this. Like this wide connections here. Yes. So on the motherboard, you can add the disk like this. Adding disk. So this kind of slots, they are called slots here. These are slots. Yes, that plugin waits nothing but slots here. They are the slots here. Okay. Yes, like this. Yes. Disk can be inserted in the slot, right? There are 12 slots. Suppose each disk, for example, each disk equal to TB. Then 12 slots. Yes, if it is 12 slots, yes, how much size? So 12 multiplied by 2 TB, right? 2 TB disk means is a 24 TB, right? 24 TB. That is low end system. Low end system 24 TB. Okay. Suppose if you want to more storage here. If you want more storage here, then yes, motherboards with 24 slots. You can purchase that system also. Motherboard with 24 slots. 24 slots, right? Yes, if it is 24 slots, 24 multiplied 2 dB here. So this is equal to how many here? 24 multiplied 2 dB. So this is 40, right? Yeah, this is reasonable storage. Recommended storage 24 in real time. In real time data centers here, this is recommended storage. 48 TB is recommended. So 24. So this is very low end here. 12 slots means low end. 24 means is reasonable here. So motherboard 24 slots. 24 multiplied 2 here. So 48 TB, right? So this in real time. Okay, real time. Yes, in data centers they will maintain like this. Okay, right? Next, one more thing here. Yes, a computer can have the two motherboards. A computer can have, yes, very high-end system. A computer can have two motherboards. If there are two motherboards, right? Two motherboards. That means 2 multiplied by 24 is equal to 48 slots, right? Yes, 48 slots. 48 slots. That means 48 multiplied by 2 TB disk is equal to here how much here? Yes, 96 TB. This high-end system. High-end system. This high-end. Suppose if you want very high-end system, very high-end here. Yes, high-end, very high-end system. If you want go for very high-end system here, high-end system, that is 48 slots. Okay, two motherboards each with 24, totally 48. 48 multiplied 10 TB disk. Yes, 10 TB disk also available in the market here. 10 TB disk available. So 48 into 10 TB is equal to 488 TB here. This is very high-end system. This is very high-end system. 48 into 10 TB. So up to 480 TB, this volume can be increased. This volume, yes, initially 2 TB. So maybe 10 TB initially here. Adding 10 TB, next 10, next 10, next 10, next 10, 10, 10, 10, 10 like this. Like this by adding here, we can increase this volume. This is called vertical scaling. Okay, see, traditional systems follows vertical scaling. Traditional systems follows vertical scaling. So increasing volume. What is vertical scaling here? It's a process of increasing volume of server. It's a process of increasing volume of server. Is a vertical scaling. Right, okay. Next, one more horizontal scaling. Hadoop follows horizontal scaling here. Okay, so this is traditional system here. So traditional systems follows vertical scaling here. It's a vertical scaling. Where is that check? Vertical scaling. It's a vertical scaling. It's a vertical scaling. Right? Next, Hadoop. So what is Hadoop storage here? Yes, Hadoop storage. Hadoop storage follows horizontal scaling here. Horizontal scaling here. Yes, horizontal scaling here. So what is horizontal scaling? Yes, follows horizontal scaling here. So what is horizontal scaling here? See, in traditional systems, increasing server capacity, one server capacity increasing, right? But in Hadoop, yes, horizontal scaling is adding number of servers, increasing number of servers. Yes, instead of one server, increasing capacity of only one server here, then making multiple servers. Yes, instead of single, this is increasing just capacity. Yes, instead of that here, making multiple servers like this, making multiple servers, right? Multiple servers. If you increasing number of servers, that is called as horizontal scaling. If you increasing volume of server, okay. Yes, when increasing volume of one server, that is called vertical scaling. Yes, instead of increasing volume of server, if you making multiple servers, adding multiple servers, the horizontal scaling. That is Hadoop files, right? Okay. Yes, adding. Yes, how to add it? How to add the multiple servers? Okay. How that distribution? Yes, the topic tomorrow we'll discuss. Today, traditional system discussed yet. Storage. Storage in traditional system discussed. Right, okay, next Hadoop we'll discuss. See all the challenges here. Big data challenges. Big data challenge, storage. Traditional systems versus Hadoop. All the challenges we'll discuss. Okay. Traditional system. What is happening traditional system? How traditional system is failing? Reason. Okay. Data storage in traditional system. How it is failing here? See this. Here, high-end system recommended is what here? 96 TB, right? Recommended is 90. Yes. Recommended 40. Sorry. Recommended 48. Suppose 48 TB, right? This volume is 48 TB. More than 48 TB data getting simply fails. Cannot. Simply just it fails. That's it here. Simply it fails. Okay. In Hadoop, there is a solution here. Hadoop provides solution. Yeah, the topic will continue tomorrow here. Okay. So everyone, traditional systems versus Hadoop here. Traditional systems versus Hadoop here. All the challenges traditional systems versus Hadoop. Yes, about data storage we discuss traditional system. Next we should discuss Hadoop. So tomorrow we'll continue that here. Tomorrow we'll continue for that. Right? Yes. Any doubts for today? Yes. Any doubts? No doubts, right? Okay. So thank you guys. Tomorrow we'll continue. Okay. So let us wind up for today.